Hey guys, I hope you all are doing really well. I so miss being in class with you. Uh, so we're going to go over today motion. It's a new concept, and so there'll be a series of videos I'm going to create on this. So motion is all based on all of this graph theory that we learned a couple months ago, increasing, decreasing, max, min. And on that same page, you'll notice that I had down below position, velocity, and acceleration. So position will correlate with the original equation. Velocity will correlate with the first derivative, and acceleration will correlate with the second derivative. So all the same relationships that we had before between original first and second derivative, we have now between position, velocity, and acceleration. Position means where's an object. Now all this motion is straight line motion. It's actually referred to as rectilinear motion, which basically means we're moving two-dimensionally. We can only go left, right, or you can only go front, back, or you can only go up, down. So that's the only type of motion we're dealing with. Later on in higher level math classes, you can deal with all sorts of three-dimensional things. But right now it's just two-dimensional things. So position is just where are we on the number line, zero, positive numbers, negative numbers, etc. Velocity basically means how fast are we getting there, but at the same time, velocity tells us direction. So velocity is speed with direction. In fact, speed is the absolute value of velocity. And then you have acceleration, which is how quickly velocity is changing. How, if you're accelerating in your car is speeding up or slowing down if you're decelerating, things like that. The abbreviations we tend to use, A of t stands for acceleration, V of t stands for velocity. Position, we use an S. Makes sense, right? 90% of the time we use an S. Sometimes they use an X, and every now and then I've seen a P for position, but most of the time they use S. The position function is also known as displacement. So here's all the relationships we need to know. If our object is moving to the right or moving up, or moving forward, basically means its position is increasing along the number line, then that means the first derivative, velocity, is positive. If it's decreasing, then the first derivative, velocity, would be negative. If the object is at rest, meaning it's not moving at all, then velocity would be zero. Again, relative maximum, that means first derivative, velocity, would have to switch from positive to negative. If there's a minimum in the position, then velocity switches from negative to positive. And so you can see all those relationships there. The ones I really want to point out down here is whether an object is speeding up or slowing down. And the basic relationship down here that I need you to know is that when velocity and acceleration are the same sign, the object is speeding up. Here it's speeding up in a positive direction. Here it's speeding up in reverse, but it's still speeding up. When those signs are different, velocity is positive, acceleration is negative, or velocity is negative and acceleration is positive, then that object is actually slowing down. Okay? Or you could say the speed is decreasing. So there's the general set of rules that we're going to go through. And then if you click on the next couple of videos, I'm going to walk through a couple different examples. I just don't want the videos to be so long that it takes forever. But so we will see you in the next one.